Hi
Hi
everyone,
everyone,
I hope
I
you're
hope
well.
you're well.
So,
So,
in
in
today's
today's
session,
session,
we're going to talk about
about
Polars.
polars.
It's a
It's a
Python
Python
package
package
which
which
helps
helps
us,
us,
put the
put the
data
data
into
into a
pretty
pretty
looking
looking
for
for
tables
tables
and
and
basically
basically
present it in
present
a
it in a
much
much
better way.
better
So,
way.
I'm
So, I'm
joined by
joined by
Tejan
Tejan
Pratap
Pratap
Singh,
Singh,
and he's
and
going to
he's going
give
to give
us
us
a
a
demo of
demo of
how we
how
can
we can
use
use
this
this
library.
library.
So,
So, let's get started.
Okay, thanks a lot for inviting me. So the agenda for today is to give you a very brief and in no way exhaustive illustration of how one can use the Polars package in Python to do very basic data cleaning. So the idea is that we have our data saved already in a machine readable format, either in a CSV or an Excel file or a text file for that matter. And we're going to import that data and try to do some data cleaning to get it to a stage where we can start doing further analysis on that, either some statistical analysis or for just purely data visualization purposes. So before I start the discussion on the Python script, I want to show you what kind of data we would be looking at today. So this is what the data looks like. This is basically one of the schools in Tanzania where the students have taken their grade 4 exams. And on this web page, we see their performance on each of the subject that they took the test in. So basically, if you can see on the screen here, this appears to be a format, a table with multiple columns. So you have the candidate number, which is the candidate identifier, their sex, their name, and the subjects along with the letter grade, and also the average grade. So the data that we are going to import has this table in a CSV format. So let me show you what I mean with that. So here we are in the visual code, and I've already fired up my Python terminal at the bottom of the screen. Let's first load the packages that we need. So we are going to load the Polars package, which we will use for data cleaning. Then the OS package is for navigating to the particular directory, and then pathlib package allows us to sort of call different files within directory. So we'll first set the root directory. So I have saved my CSV file in the desktop. So I'm just going to go and pull out the path to desktop. So I have copied the path. I'm going to call the OS package and specifically the chdir function, which basically allows us to set the root directory. So let's copy in here. And because we need the path to be in the / format, so I'm going to just remove and edit all the backward slashes with the forward slashes. Okay, so let's run this. So I'm going to right click here, and then I'm gonna run this in the Python terminal. So as you can see, it worked, and we can see what the uh, current directory is. So, oops, okay. Some reason this is not cooperating. Okay. Let's try one more time. Okay.
Path dots.
Okay. So I made this wrong. So we need from the path lib, we need a specific sub package, and that's what we are going to call here. So this should work now. and let's see if we were able to set our working directory correctly. As you can see,
Wow.
the output says that the working directory has been set to the desktop. So the file on the desktop is this CSV file here. So I'm just going to go ahead and import this into the Python console. So let's do that. So we are going to use one of the packages, one of the functions in the Polars package. This is called the read underscore CSV. And if you go to the API reference for Polars, you can get more information on this. So let me just show you what I mean with this. So there is a search bar at the top right. So if you write read underscore CSV, it gives you more information about the exact arguments for this function. So you can see it has a whole lot of stuff which we don't necessarily need. We'll just use the default setup. But this allows you a lot of flexibility in terms of reading the data. And they also have some examples at the bottom which may help you. So I'm going to use this package here and import our data which is saved in the CS. So let's do that. I'm going to call the object which I'm going to assign this data to as DT. So I need an equal operator, and then I have imported here. You can see I've imported Polars package as PL. So I have to call the read CSV function from here, and Visual Code helps us. It gives us prompts. So now one of the arguments, if you would see in the read underscore CSV function, is source, and this basically can be the path. You can see that it takes path as the input. So we are going to give the path to the file. So I'm going to use the path directory, and then there is a join path function, which just will take because we have already set a root directory, we just need to give the name of the file. So we are going to give that, and hopefully this will work. So let's execute this and see what it does. So it appears that it has worked, and I can print the file. So you can see that the data got imported. It has 69 rows and 13 columns. So let's look at what these columns are. So again, using the columns function of the Polars package, I can get the list of the names of the columns. Okay, so I need the data name and then columns. So here you see it gives me a list. It prints a list of the column names. So we don't actually need all the columns here. So what we can do is we can drop the columns that we don't need. So I'm going to use a bit of list expression in Python, which will allow me to create a list of the column names that I want to draw. So let's do that. So again, I'm going to assign that to the object that we have already created. And then we are going to use the drop function from the Polars package. And it takes the list of the column names that you want to draw. So what we are going to do, we are going to keep the candidate name, sex, their number, subjects, average grade, school name ID, region name, and distinct name. And we are going to drop all the other columns. So let's use an list expression. So x for x in dt.columns, if x not in. So what are the columns we want to keep? We want to keep candidate identifier, which is candidate number, their sex, their name, and then individual subject letter grades, average grade, and school name ID. And then finally, the region name and the district name where the examination center of the school is located. So if I was to just run this list comprehension, you would see that it's going to give me a list of the objects that will be dropped. So let's see. So you see, this gives me a list of the objects that I don't, the list of column names that I don't want, right? So let's go ahead and drop the columns that are no longer needed. So just to sort of, for the ease of the viewer, let me just first print the current data as it looks like, and then the existing one, you will see that these columns will no longer be there once we have dropped the columns that we don't need. So let's do that. Okay, it appears that it worked. So let's see. Now you can see that those columns have gone, and we only have the 8 columns that we wanted to keep. So you can see that the data is now ready to be manipulated further. Uh, uh, so this shows you or gives you an example of how easy it is to import the data and do some very basic data wrangling using the Polars package. And this package also allows you to do the same sort of stuff with very big data. In my personal work, I have used the Polars package to create clean data with multiple columns having millions of observations. So that's it for this module. Thanks a lot for joining in. And yeah.
Brilliant.
So thank you
So
so
thank you so
much
much
for your
for your
time, and
time,
we'll
and
see you
see
guys
you
in the
guys
next
in the next
video.
video.
Thank you.
Thank you. Brilliant. अब दूसरे वीडियो